Hey, everybody, my name is Justin, and I am here today to share with you a few problems as we consider relative maxes and mins and real zeros and how to find those using the TI technology. So let's jump right in and take a look at problem one here. So, problem one asks about a theme park. It says a theme park determines that it can project its profits in thousands based on the number of passes it sells in thousands using the given function. How many passes must the theme park sell in order to maximize profit? And what is that maximum profit? So, very simply, let's type the function into the TI technology. So, we're going to go there and we will hit y equals and we will enter the function in y1. Bear with me, I'm going to go back and forth to make sure I get the function entered correctly. As should you, right? Be sure that you enter information correctly into the technology. That's probably one of the leading causes of getting an incorrect answer is information is input incorrectly. So always double check what you type in and be sure that you have it in correctly. So let's type it in negative 2x squared. Negative 2x squared. We have a plus 260x. And a minus 7,500. Let's do a zoom 0 on this. And you can see we're not seeing everything that we need to see on that particular function. So let's zoom out a little. Let's zoom out again. I want to see that vertex. So we'll hit zoom option 3 and we'll hit enter. And there we are. So now we can see the vertex here. And let's go back to the question to make sure that we're answering what it's after. So theme park determines it can project based on the number of passes. Here's the function. How many passes must the theme park sell in order to maximize? And then what is the profit? So really, we need to know that vertex ordered pair. So let's go and find that. We're aiming for this ordered pair here at the vertex. It is a maximum. So we will second calc, and we will select maximum option 4. Left side of that maximum, we will hit enter. Right side now, we will move our cursor over to anywhere on the right-hand side of that maximum and hit enter once more, and it will ping the maximum. All right, so there we are. So our maximum is at ordered pair 65 roughly, or essentially, right? This is 65 and 950. All right, so we answer the question now. How many passes must the theme park sell in order to maximize the profit? Well, the number of passes is the x coordinate, and it is in thousands. So we have, it would be 65,000. That would be the number of passes that we would need to sell in order to maximize the profit. Again, passes is x coordinate and it's in thousands. So the number we would need to sell to maximize profit would be 65,000. And then the following question, what is that maximum profit? Well, that profit is the P value, or in this case, right, that's just our output or our Y value. So that's the Y coordinate of that ordered pair. And again, it is in thousands. So what is that maximum profit? It would be 950,000, right? $950,000 would be the maximum profit at 65,000 passes sold. So there is problem one, and how to find the vertex and use it to interpret in context the result. So let me clear this and let's move to a second problem. Problem 2, use the graphing calculator to find the relative max and relative min, round if necessary. So let's just practice inputting functions into the TI. This is absolute value of x plus 3 minus 2. So we'll go to y equals, and let's clear out our old function. Absolute value is found by going to math, number, and then the ABS command. ABS for absolute value. absolute value of x plus 3, and then minus 2. So we'll have an x plus 3, and then we'll arrow out. And outside of the absolute value notation, we will enter minus 2. Let's do a zoom 6 on this to get a standard view. There we are. This function will have no maximum, but it will have a minimum. That minimum is evident right here. So let's go find it. Second calc, we will select option 3. This is a minimum. We want to be on the left side of the minimum to start. Notice the question says left bound. So let's be on the left side, hit enter. It'll change. Now let's move to the right side of that minimum anywhere, hit enter. It'll say guess, hit enter one more time. What you're doing is setting up a viewing window for the calculator to go search in. And it does the work from there. You're just setting a left side and a right side for it to focus and search within. And within that little window that you give it, it will find the lowest, in this case, minimum value there, and it will ping it, and that's for that portion of the function. Here, it's the overall minimum. It's an ordered pair, -3, -2. So there's our minimum, and that's the only relative extrema for this function, -3, -2. Let's come to this guy. Function negative x cubed. So let's clear this out. We'll go y equals, clear this. We'll go negative x cubed plus 3/2 x squared. Always best to put fractions in parentheses. Plus 6x and a minus 3. Let's double check that we entered that correctly. Okay, so it's a negative x cubed we have, plus 3/2 x squared, plus 3/2 x squared, very good. And then plus a 6x minus 3, plus a 6x and a minus 3. There we are. All right, let's do a zoom 6 on this again. And there's our function. Now we know, because the nature of this function is cubic, that what we're seeing here is the main interest, right, of the function. A cubic function will have kind of 3 directions that it takes, hence the highest power being 3. So we're going downward, that's 1, come up again, that's 2, go down again, that's 3. So what we know is this will just continue to increase toward infinity. This will continue to decrease toward negative infinity. So we're kind of seeing everything that we need to be seeing. So where are our relative extrema? Excuse me, they are here. That's a relative minimum. And here, a relative maximum. So let's find them. Second calc. Let's find the minimum first, so that'll be option 3. Left side of it, so go anywhere to the left of that minimum, hit enter. Arrow now anywhere to the right of that minimum, hit enter again, and it will ping it. We have -1, -6.5. -1, -6.5. Let's find this maximum now. So second calc, we will select option 4 for max, and we want to go over toward it and be anywhere on the left side of that max. Hit enter. Now we'll be on the right side, anywhere on the right side of that maximum. Hit enter again, and then guess, hit enter one more time, and it will ping it at 2, 7. There's the value of the maximum, or relative maximum, for this function, 2, 7 ordered pair. All right, so that's how to tackle that. Let's make sure we got everything for problem 2. Find the relative max we did and relative min of the function, and we certainly did that. There we go. Let's look at problem 3. A disgruntled student throws a math book from a water tower that's 384 feet high. As it's falling, its height is given by this function, where t is time in seconds. How many seconds will it take for the textbook to hit the ground? This kind of sounds like one of those 2 trains are leaving a station at the same time, one traveling this speed, the other that speed. It sounds very, how to say, intimidating. It's not bad. Let's check out this function and see what it looks like. Let's go to the technology. So let's clear this out. And let's reset our key press history, we'll go to y equals, we'll clean out the last function, and we'll type in our new one, 384 minus 16x squared, right? 384 minus 16x squared, okay? That minus 16 business, that's kind of coming from, in context, this is coming from the effect of gravity, right? That will have on the falling object. So you'll see that a lot in falling object scenarios, that minus 16t squared or minus 16x squared. That sort of comes from a conversation around gravity, right? Acting on the object and forcing it to fall. Okay, so here's our function. Let's double check that we've got it in. 384 less 16x squared. 384 less 16x squared. Very good. Let's do a zoom 6 on that. This is a parabola. You'll notice, hey, I don't see the vertex. Okay, the function here is quadratic. I don't see the vertex. So, hey, let's change the viewing window. So let's do a zoom 0. And oh, now we see a much better view on this function. We can see the vertex, we can see the form and the shape of the graph. So this is super helpful. So the question is, well, hey, it's thrown from a water tower that's 384 feet high. That's here, right? All of this stuff back left of that vertex is not in context, right, a part of the scenario. It doesn't make sense to have negative time, right? So anything on the negative side of the x-axis does not make sense, right, to be a part of this conversation. So really, we're just going to look at the right-hand side, right, on the positive x-axis of this parabola. So let me kind of set the viewing window to support that. So let me let the x minimum be 0. And you'll see what happens. Now I'm just looking at the right-hand side of this parabola. I'm actually going to reset it to be like -1, just so that I can get a good read on what that vertex is. We know it's going to be, I think it should, let's test. It should be 0, 384, right? 0 time has passed, and we're at a 384 foot height, right? That would make sense. No time has passed. The object is still at the initial height, 384. Let's just see. Second calc, this is not part of this problem, but something of interest. Let's find that maximum, right? So let's back it. Let's go to the left side of that max. So here we are now somewhere on the left, right? You see it right there. Now let's go somewhere on the right. Okay, there we are. We set the viewing window, hit enter once more. Certainly we have 0, 384, all right? E minus 6 means you're going to take this decimal, move it to the left 6 places. That's dot 0, 0, 0, 0. Okay, you're 0. So that's 0, 384 as expected. Question though is, how long does it take, right? How many seconds does it take before the textbook will hit the ground? Well, if I look at this graph, where is ground level? Ground level is the x-axis. So we are interested in the value or the ordered pair when it is an x-intercept. All right, the place where it crosses or hits the x-axis is exactly where it hits the ground and when it hits the ground. All right, so think of your x-axis as ground level. So we're interested in this ordered pair here. So let's go second trace, and we're looking for an intersect. Okay, specifically the x intercept. That's a lie. We're going to go to option 2, a 0. Excuse me, 0. 0 is what we're interested in here. That is another way to say x-intercept. Okay, x-intercept or root or 0. Those terms are interchangeable. All right, so here we're looking for where or when it hits ground level. That is an x-intercept. That is called a 0, right? So that's what we're interested. So let's hit option 2 for a 0. We'll hit enter. We want to be somewhere on the left side of this 0 or x-intercept. Well, my cursor's up here, So I mean, it's fine where it is, but let's kind of get a little closer to the x-intercept. All right, so we are now on the left side of the x-intercept. So we'll hit enter. Now we're going to go to the right side of it. So notice my cursor will go to and through it, and we are to the right now of our x-intercept somewhere. So we'll hit enter. Guess, we'll hit enter again, and we see that, oh, we hit ground level, right? Now notice units here, t, which is our independent piece, is the time. So we are at ground level, or a height of 0, at roughly 4.898 seconds, so just shy of 5 seconds, right? That t value is in straight seconds. So we can say, oh, when will the textbook that's being thrown from the water tower hit the ground? If it's modeled by this function, well, it will hit ground level, or a height of 0, at roughly 4.9 seconds, so just shy of 5 seconds. All right, will be the result here. All right, let's look at a couple more, and then we'll kind of call, hey, this is a great resource and support for us as we consider this idea of mins and maxes, all right, and real zeros using the TI technology. So let's look at a rocket scenario. Let's go back here. We'll clear out this. We'll clear out this, and we'll set up for a new one. A rocket is propelled upward from ground level at a particular speed. The height is given by this equation. Determine the max height and how long does it take to reach the max height. So twofold question. We actually get both answers in one, which is a great thing. We get a 2-for-1 here. So let's type this guy in. Remember, t we'll just replace as x in our ti. So let's go to y equals. We'll clear out the old one. And we'll type in -49x squared, -4.9x squared plus 98x plus 98x. Okay, so a rocket is propelled upward from ground level. You'll notice, hey, the speed here, 98, well, that's where this 98 is coming from, right? So we're seeing that this is making sense as to why the model is how it is. The height given here, we want to determine the max height and then how long it takes to reach that max height. All right, so in other words, we got to find a maximum. So let's make sure we've typed this in correctly. -4.9x squared, -4.9x squared plus 98x plus 98x. All right, so we have that. Very well. And let's do a zoom 6. That's just a good place to start. Notice we don't see anything. Let's do a zoom 0. All right, now we're starting to see it. Now look, here's our max, okay? But it's not in a really good position to access. So let's zoom out a little. See if we can see it better. There it is. All right, so we've got a good viewing window. Well, let's ping it. Let's go second trace. We'll go to maximum, option 4. Anywhere to the left of it, we're already there. Hit enter. Go through it and on to the other side, right side of it. Anywhere, we'll hit enter once more, and we have it now at 10, call it, and 490. All right, well, that's all we need. However, let's make sure we know what the variables mean and interpret, the correct context. So 10, that's the input. Well, that's a value of t. T is in seconds, right? So that's the answer to the how long. So how long does it take to reach the max height? Well, t seconds. T here is our x coordinate. It's in seconds, so 10 seconds, right? It takes 10 seconds for that rocket. Here's where it's launched from, right? Negative t doesn't make sense. All this stuff on the left half of this viewing window is irrelevant. The rocket is launched from here, goes up into the air, hits its maximum, and then falls to the ground again, right, and stops. This is also negligible, right? This is not sensible to consider in the context. So we're only looking from launch point, maximum, hits ground again, right? So it's just this little piece that is in this conversation, right? That's the only part of this curve that makes sense to discuss. Okay, so there's our maximum. It takes 10 seconds. Let's kind of zoom in there. Let's zoom in a little bit. Zoom in here. There we go. So our rocket is launched, hits a maximum, and then falls to the ground again, right? This is our kind of view of interest in this context. So let's go ahead and hit once more that maximum, option 4. Anywhere to the left of our max, enter. Go anywhere to the right now of our max. Hit enter, enter again, boom, there it is, 10 and 490. So independent variable here is t for time, that's the x coordinate. 10 seconds is the amount of time it takes to hit the max. Follow-up question, determine what is the max height. Okay, well, the max height is 490. Units of that are in, let's see what it said. It's height in meters. Okay, so there it is. So it's in meters. Height in meters. So it's 490 meters. So the maximum height is 490 meters, and the time it takes to reach that height is 10 seconds. All right, so that's pretty cool. Very nice. All right, let's find the real zeros of this guy. Little intimidating. We're seeing some exponential things going on, some quadratic, some cubic stuff all mixed together. So let's kind of see what we can get into with this last one. Just a quick, practice problem to practice the skill of finding the real zeros, okay, or the x-intercepts of a function. All right, let's type it in. Let's go to y equals. We're going to clear out the old one. This is 3 raised to the x power. We'll arrow out. Plus 4 to the x. 4 raised to the x. We'll arrow out. Minus 3x squared. And then minus 5x cubed. Okay. Again, as we stated, let's double check that we have it entered correctly. That matters. All right, I got 3 to the x plus 4 to the x minus a 3x squared minus a 5x cubed minus a 5x cubed. There we are. Okay. All right, and that's it. Good. Okay. Let's do a zoom 6 on this. See what we can see. All right. Maybe a zoom 0. I'm just trying to get a good view of this thing. I don't know if the zoom 0 will, a little too much. Let's go back to a zoom 6. There we are. All right. So let's get our real zeros, right? That's what we're after. We want the real zeros of the function. So it looks to be that those real zeros are here, right? That's one place it crosses the x-axis, and here, that's the other place that this guy crosses the x-axis. So let's go and find those. So we've got 2 to determine. So real zeros, those are roots or x-intercepts. So let's go second count. We'll select option 2 for 0. Let's go after this one first. Notice we're already to the left of it, so we'll just hit enter there. Let's now move it anywhere to the right side. So we're slightly now to the right of that 0. So we'll hit enter again once more, and there's one of them. So one of the zeros, right? Look at that y value, it's 0. That's why we call it a 0. So y value is 0. And that occurs when x is .9096, roughly, okay, if we round that. So there's one of the real zeros. It's at an x value of .9096. So there's one. Let's go grab the other one. So we'll repeat the process. Go second trace or second count, option 2 for 0. Let's kind of get over here, closer to this other intercept. I mean, the cursor goes off the screen. You're certainly to the left of it. Just hit enter is fine. Now I just want to go to it and through it to the other side, and that'll be on the right. Let's see if our cursor comes back down from the basement here. It may have jumped. Yeah. See, I keep clicking it and it's not even moving. So what's happened is x is already at 10, so it's way over here and somewhere way up in the air. So it quickly, you see how sharp this incline is. It went from way down here to way up there real fast, and we didn't even see it go by. So we'll just take it as where it is. Notice when I hit the arrow, it pops up real little right here. So the calculator will search for a 0 between here and there, so it'll certainly ping it. Guess, just hit enter, we've got it, and there it is. So your other 0, right, where y is 0, your other 0 occurs at x 4.144, okay? You can report that as your second 0 or real 0 of this function, 4.144, we'll call it, okay? So the graphing calculator to find the zeros, we did that of that function. So we have completed this Math Minute. Let me stop sharing and kind of come back to life here. And I want to thank you for joining, and I do hope that this was helpful to you. If you have any questions or needs or would like further support, please reach out to your instructor. Please review the video again, connect with a peer, and continue studying and learning. And I look forward and wish you all the best success. Again, I hope this was helpful, and connect with any questions or needs. Have a wonderful day and all the best.